minimum number of operation to satisfy condition. In this problem we have given a grid of size n cross m, and in one operation we can change the value at any cell to any non-negative number, and they are asking that you need to perform some operations such that the value at each cell grid ij is equal to the cell below it, and it is different to this cell to its right. Now let's understand this problem by example, and they are asking that they return the minimum number of operation needed. Now let's take example 1 1 1 0 0 0. As they are asking that if we, for every index the value right to it is, it should be different, and value down to it will be same. Now for 0 0 the value right to is same, but they are asking in question that the value right to any index should not be same, so we have to change this value. So let's change this value to 0. Now for down they are saying that this value should be same, so we change this value to 1. So for column 1 we require two operation. Now let's move to, now for index 0 0 we require two operations. For index 0 1 the value is 0 and the value to its right is 1, which is different, so it is true. And for value down to it, del value down to cell 0 1 is 0, which is same. So we have to perform no operation as already conditions are met. So we move to next index 0 2. For 0 2 there is no right index present, so we do nothing. For value down to it the value is 0, but in question they are asking that value down to is always should be same, so we change this value. So for this we require one operation, we change its value from 0 to 1, so we also require one operation. Now let's move to index 1 0. For its right the value is 0, which is different, as there is no down cell, so we do nothing. For now let's move to index 1 0. For 1 0 the value right to it is 1, which is different, which met our conditions, and there is no down cell. Similarly for 1 2 there is no right cell and no down cell, so we perform nothing. So in this case our answer is 3, which is minimum, and we cannot further reduce this answer to make this matrix so that our all the condition are met. So now let's see that how we can approach this problem. Now firstly we see the constraint. Now after seeing the constraint we can see that the size of matrix is n cross m, and the value of n and m is from 1 to 1000, which is small. And the main thing noticed to that we notice in this problem is that grid ij value, which is only from 0 to 9. Now firstly see how we can approach this problem. For this we can see that we have to first approach that come in our mind is that we change all the value to 0 in first column. For second column we make it to 2, or 1, then in third we make 1, and in fourth we make 3, but it does not give the minimum as the condition are met, but they are also asking that we have to return the minimum. Now let's see that we have given a matrix of 4 and we are given 0 0 0 1 1 1 0 1 0 1 1 1 1 2 2 1 1. Now for as we have to perform the minimum number of operation, so we always check that the number which is present maximum time in a column, we choose that number and make all other value in that column to the column which is to the element which is present maximum time in that column. So for column 1 we make all the value to 0, which required only one operation. So required one operation. For second we change all the value from value to 1, which also required one operation. For third it is already 1, so we require 0. For second we, in this the 2 is present 2 times and also 1 is present 2 times, so we require only 2 operation in both the cases, so which is 4. So we require 4 operations, so we require 4 operations to get our answer in this case. But we can see that they are asking that value to its right cannot be same, but in this case we choose 1 1 1 in second column, and for third column we also choose 1 1 1, which violate our condition that the value to the right should not be same. So we cannot directly take the value 1 in this case, so we have to change this. By doing this we come to a situation that we cannot directly apply greedy in this problem, so we have to check, so we can apply recursion to solve this problem. So now let's see how we can apply recursion. The main as the value of grid ij, the value of grid ij is from 0 to 1, only from 0 to 9, sorry 0 to 1, sorry my bad, is from 0 to 9. So we can check this recursively by taking that we can, for let's take example, for first index we take 0 0 0, try 0, firstly we try 0 0 0, then we try 1 1 1, and further 1 1 1 2 1 1 1 2 2 2 3 3 3. Now we recursively, for this we recursively check if we apply 4 4 4 5 5 5. For every index we have, for every column we have 9, we have 10 value to check. First we check for 0, then 1 2 3 up to 9. So for second column we also have value from 0 to 9, third 0 to 9, 4 0 to 9. But we do not always need value, as there may be a case that if we are choosing value 1, we are given a matrix 0 0 0 1 1 1 1 0 2 2 2 3 1 1 2 1. Now for this, if we are choosing 0, then we only require 2. For 0 we only require 2 operation, because already 2 is present, already 1 is present, 0 is present 2 times. If we choose 1, 1 is also already present 2 times, so we require only 2 operation more, because the size of the number of rows in this matrix is 4, as the matrix is 4 cross 4, so we require only 2 operation. If we are choosing 3, then we require 4 operation, because 3 is present 0 times. Because 3 is present 0 times, so we required 4 operations. Similarly for every other value we required 4 operations, because that value present 0 time except 0 and 1. So similarly we check that for every column. So rather than checking it every time, we make a vector 2D array in which we are storing that how many times that value present in that column. For that, let's take this example. Now we we make a 2D vector of m cross 10, where m is the number of columns and 10 is the maximum, because we can only, because the value of grid ij is from 0 to 9, so we need m cross n 2D matrix which can store all the value. Now for first column we make a vector of 10 size 0 to 9, and if for index 0 we that for index 0 its value is 2, for index 1 its value is 2, for other it's 0. Then we make this for all the column. So our so the maximum number of so the size of this 2D array is m cross 10. So firstly we pre-compute this, and then we recursively check how this then we recursively check how many minimum number of operations required to do this problem. Now let's see code. Now first in this code we iterate from 0 to m. Firstly we iterate for every column. We iterate the whole row. For every column we iterate the column from 0 to n, and we check if the value is present. dp of v of j comma I, we increase the value by 1, and we declare the value of dp is of size 10. Then we push this in vector. This will make our 2D vector, which give us the how many times that value present in the column. Then we call the function which taking 3 parameters. First is t, the vector which we have calculated the value, and index 0 and the previous value. Now let's understand this recursive code. In this recursive code we firstly now let's write the recursive code for it. Now let's take this is t array which we computed, and index and the previous value. The previous value tell us that if we are the for first index if we are, let's take for first column number first, second, third, fourth. For first column we can take any value which we want, because there is nothing present to it left. So this value is not become the right value for any other cell in the matrix. So we can write anything which we want of our choice in first column. We can write 0 0 0 0 1 1 1 2 2 2. So if the previous value is initially we write our previous value to -1. If our previous value is -1, then we can take any value from our choice from for I 0 to 9, I equal to 0 to 9. Then we have to count the number of the value times that I is present in that column. But how we can do that? As we have previously calculated the value, we can directly get it by doing v of index comma I, which gives the number of time the value I present in the column index, because we are taking the firstly we are taking first column, then we second, third, fourth, fifth, and so on. Then the number of operation we required to make all the values same in this column is n minus the number of time which is currently that number present in that column. So we recursively call this function for next index and choose our answer, the minimum of the answer comma answer 1 that we get by this. Now if the previous value is not equal to -1, then we also move from value 0 to 10 0 to 9, and if the value of I is equal to previous. Now let's understand. If we take 0 0 0, then for next column we cannot take 0 0 0, because it's violate our condition that the value right to any cell should not be same. So we cannot take 0 0. For that case we continue, we move. Then for other we similarly perform the Same we perform in above. For the number of operation required is equal to n minus v of index comma I, index I, and then answer we can answer to equal to operation plus, because we required that much of operation plus we could recursively solve that problem. At last we return the minimum numbers of operation that is required. Now if we solve submit this problem, this will give us TLE, because it's very it take very large time to compute all this value. So we memorize, as there is a overlapping sub problem, so we memorize this problem. We declare the dp dp array as the index is, as we already, as there is a one of the best way to write a memorization is that by taking the parameter that which the parameter which are changing, we simply make the dp for that parameter. In this, the parameter changings are index and pre, and the value of index should be from 0 to 1000. So we declare a 2D vector of 1010, and pre value is always from minus 1 to 9. So we take it's of size 20. If we take size of it of size 10, it also works. But for minus 1, for previous value we are always adding 1. Now let's see why we are, for if previous value is minus 1, as their index started from 0 to 1 to further, we are taking for size of 20, so it's from 19. If we take as our previous value is minus 1, as there is no index, it give us error. So we always add value 1 to our previous while storing it in dp, and also while retrieving it from dp. If the value, firstly if we where we return answer, we simply store it is in dp, and if check if value is not equal to minus 1, because we are initializing our dp to minus 1. If our value is not equal to minus 1, then we simply return that value, and this, in this way we can solve this problem. So let's try to submit this problem. It's working.